Hello students, welcome to this video tutorial on solving algebra problems with Algebra Tile Supernote Part 3, multi-step problems. Okay, so the title alone should hopefully give you a clue of the strategies involved in solving these type of questions. So what we're going to do is we're going to combine the strategies from Part 1 using addition and subtraction and with the strategies you learn in Part 2 using division. Okay? All right. So let's start with question 6. All right. So I've given you more room here, and there's going to be a good reason for that. The reason is because it involves one more step. Okay, so you're getting very good at drawing algebraic equations and expressions using tiles. So let me give you a head start. I would like you to draw this question. Okay, so hopefully for diagram 1, you came up with this diagram. 2x minus 3 equals positive 3. Okay, so when it comes to multi-step problems, here's what I want you to remember. I want you to use strategies in reverse Bemza order. So what we're going to do is we're going to wait to do the division till later. So what I want to do is I want to focus, right, remember we always have to focus on whatever side the variable is on. The variable's on the left-hand side, and I want to get these variables alone. So the first thing I want to handle is the negative 3. Okay, so let's recopy what we've drawn. Okay, since the x's are on the left-hand side, I'm only going to focus on the left-hand side. So I want to get rid of the 3 negative tiles. So remember how to do that from our part 1 video? To get rid of 3 negative tiles, we add 3 positive tiles. And it has to be exactly 3 positive tiles because I don't want to have any leftovers here. I want to create perfect zero models. And whatever I did to the left-hand side, I have to do to the right-hand side. Okay? All right. So I'm going to imagine that these 6 tiles, these 3 zero models are gone. So what would I be left with? I would be left with 2x equals positive 6. Okay, so here's now where we use our part 2 video strategies of making groups. Well, we have 2 x's on this side, so we're going to divide it into 2 groups stacked on top of each other. Okay, then we have 6 positive tiles that we have to separate into 2 separate groups. Good thing is I've already got them stacked here, so that was pretty lucky. I wasn't even thinking ahead for that. Okay, then do you remember what we do? When we have 2 x's, we're dividing by 2. We're going to circle one of the groups and show that we are going to take them away. And then we always have to write here what we're dividing by. In this case, we're dividing by 2 because there are 2 groups. There are 2 x's. All right, and then our last diagram, step 4 this time, is we draw what remains. what remains is x equals positive 3. Okay, so do you see how we combine the different strategies in one question? That's why they're called multi-step. Because we had to use, in this case, we had to use addition first, then division. Reverse BEMSA. If we were to normally solve a question using BEMSA, we would normally do the division first. But in algebra, in this type of question, we have to do the reverse. Okay, so how's that going to look algebraically? Step 1, we always copy the question. Step 2, we always start with copying the question. Okay. So remember, I want x to remain alone. X is on the left-hand side. I'm only going to focus on the left-hand side right now. So what's in the way of x being alone? Well, we have times 2 and we have subtract 3. So let's get rid of the subtract 3 first. Well, how do we get rid of subtract 3? We do the opposite. We add 3 on both sides. Subtract 3 plus 3 minus 3 plus 3 cancels each other out because its net value is 0. 3 plus 3 is 6. Okay? So then in step 3, we write down what remains. We have 2x equals, remember, negative 3 plus 3 cancels each other out. 3 plus 3 is 6. So I'm almost finished. Now this question should remind you of the questions that we did in part 2 in the previous video. So I want x alone. What's in the way of x being alone? Times 2 is in the way. How do I get rid of times 2? Well, we do the opposite of times 2, and that is we divide 2 on both sides. You have to remember to do whatever you do on the left side, you have to do on the right side. 2 divided by 2 cancels each other out because 2 divided by 2 is 1. 1x is simply 1. 1x is simply x. 6 divided by 2, well, that's easy. That's 3. Okay? And then step 4, we write what remains. What remains is x, because this is actually 1x. We don't write the 1, equals 6 divided by 2 is 3. Last check, we see that our tile diagram solution is equal to our algebraic solution, and that's what we want. Okay, so again, a question combining all of our strategies into one. So let me give you a head start on example 7. All right, step 1, we draw the question. We represent the question. All right. Now there are a lot of tiles to draw on this question. Oh well. So to begin step 2, we copy the question so that we can work on it. Okay, so let's think about our strategies. What side is the x value on? Well, in this case, it's on the left-hand side. Now, all of the questions on the supernote, the variable was on the left-hand side. The x value was on the left-hand side. But it doesn't always have to be on the left-hand side. I could have easily put it on the right-hand side. Okay, so don't automatically think that the x is always going to appear on the left-hand side. All right, so we have 3x, and then we have positive 2. Remember, we eventually want to have x alone on the left-hand side. So let's tackle the positive 2 on the left-hand side first. So to get rid of positive 2, hopefully you added 2 negative tiles here to create 2 zero models, okay, which we are going to eliminate. Now, because we added 2 negative tiles on this side, well, we have to add 2 negative tiles on this side, okay? So when we go to step 3, we got to think about groups now. So all that remains on the left-hand side is 3 x's. So let's separate our 3 x's. We'll stack them on top of each other to show 3 different groups. Okay? Now on the right-hand side, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 negative tiles. Well, how would you separate 12 negative tiles into 3 even groups? Well, hopefully you would put 4 negative tiles in each group. Okay, so we still have the 12 negative tiles on the right-hand side, and we still have the 3 x's on the left-hand side. Okay, so we want to circle all of the groups except for one, because we want to have one group remaining. And it's not a zero model, but we're showing that through division, it's being taken away. What are we dividing by? We're dividing by 3. Even though we circled 2 of the groups, we are actually dividing by 3 because there are 3 groups. And let's draw what remains, our answer. Our answer is x equals -4. Okay. All right, so let's look at the solution algebraically. Step 1, copy the question. Step 2, copy the question, and then we start to work on it. Okay? All right, now the variable x is on the left-hand side of the equation, on the left-hand side of the equal sign. So we want x to remain alone. So we have a number of things kind of in the way of x being alone. We have times 3 and we have plus 2. So let's get rid of the plus 2. We're going to use reverse Bemza here. So to get rid of a plus 2, we subtract 2 on both sides. So plus 2 subtract 2 cancels each other out because it's actually 0. Negative 10 subtract 2, remember your integer subtraction rules, is negative 12. Okay. Step 3, let's write what remains. Well, what remains here is 3x, then we have equals, and then what do we have? Minus 10 minus 2, we already said is negative 12. Okay, so we're on our last step. We want x to be alone. What's in the way of x being alone? Times 3 is. To get rid of a times 3, we do the opposite operation, which is divide by 3, but we have to remember to do it on both sides. 3 divided by 3 cancels each other out because its value is 1. This remains as 1x. negative 12 divided by positive 3. Well, negative divided by a positive is going to be a negative. 12 divided by 3 is negative 4. Okay? Finally, step 4, we write what remains. 3 divided by 3 cancels each other out. We're left with x alone, which is what we wanted, equals negative 12 divided by 3 is negative 4. Okay, so I hope that made some sense. And this concludes the solving algebra problems with algebra tiles super note. Thanks for watching. Bye.